I'm Jonathan Halstich, the Chief Operating Officer at Racktop Systems, one of the founders. So I named my talk Darwin Storage when George asked me to speak here, partially because our primary purpose for starting to use ZFS was for storage, and it seems like a very adaptable file system. You can pretty much, it seems like, do anything with it. And also, it's very much evolving. I think in the spirit of this conference, everyone's coming together to evolve the file system to make it better and to improve it to the next level. So I want to give you a little bit of background on myself and the company. So Racktop was founded, it's an IT products company, and ZFS is an integral part of the products we sell. So we sell a storage solution, Brickstore, which is a ZFS-based storage appliance, and we also sell some products, one of them being VBox, which is basically a VDI in a box solution that has a ZFS-based storage component in it and can serve VMware View desktops very easily. Since VDI is kind of heavily dependent on the latency of your storage, it's been a big challenge, and what we've done is simplified that to create an easy way to do it, and ZFS was kind of the perfect solution for something like that. From a personal perspective, I've been an IT consumer where I've bought products from pretty much all the major companies and some of the smaller companies, and I've kind of dealt with the challenges of bringing a new product into an enterprise, getting it to work, and deliver the promises the sales guys sold me. I actually came out of the government federal space where I was working in a large organization, and you had more money, more people, and a lot more problems. So kind of changed now to a business owner where we're using ZFS to run our business as well as create products for other customers so they can have a successful business as well. And that's where the product provider piece comes in. I, like pretty much everyone else here, actually everyone else here has worked at Sun and Oracle. I've never worked at Sun and Oracle, so I kind of feel like an outsider, but a different perspective, I guess. So one of the core beliefs we have at Racktop is that technology should solve a specific business problem or challenge. I think Brennan Gregg's made comments a couple times saying, you need the script to solve. You don't just write a script for the purpose of writing a script. There's got to be some sort of use case or purpose. And fundamentally, all the things we try to do is solving a specific problem that we've either run into in our own lives, either running the business operations and saying, hey, I wish I had a way to do this, or a customer comes to us and says, we have this challenge, how do we get past it, and work through the problem with them to do that. So we kind of chose ZFS originally because of the optimized components. So you kind of had, the ZFS intent log, the write cache, you have the L2ARC, things like the read cache, where you have kind of components that are optimized to do something. So instead of having something that's, good at all things, finding the thing that it's great for, and choosing the right tool for the job at the time to specifically deliver on that promise. And I think one of the coolest features that I like about ZFS is that it has the ability to adapt on the fly, assuming you have the proper kind of pre-thought planning, architecture, and components. So, ZFS is dependent on kind of that foundation you build it on, the hardware, et cetera. So, like we just heard, sizing, should you buy more RAM, should you put more, if it's a storage solution, should you buy more SSD, what type of SSDs, all those kind of underlying components matter. And, to go all the way back to Ben's speech where he talked about keeping it simple to understand, what's going on and to be creative. You don't want kind of these one-off creativity things. You want things to kind of evolve as a system and understand how things are going to fail or work. And so we've spent a lot of time to figure that out, to figure out the failure modes, to understand what is the right way to size things. And kind of the things you've heard, we've spent a lot of time studying as well to figure out how do we architect a storage solution that's going to be optimized for a customer. So when you, as a person, go and say, hey, I want to buy a solution, is my money really well served, buying a lot of L2ARC SSD, and what type of SSD do I need to buy? There's all these kind of questions you're asking. And then once you've purchased it and you have it, that new storage array in your system, choosing how you're going to do the VDEV layout can matter, because kind of once you make that decision, you start putting real data on it, and now you have production customers, and it's a large array, it's not too easy to change midstream and say, I really should have went, like a RAID 10 striped VDEV instead of the RAID 6 I chose. And those things and that forethought really matters. And so, I think the more you know getting into it, the better off you are, which is tough. But the other flexibility is you can add more cache, right? So things like L2ARC allow you to change on the fly later on. You can add other things that expand. So it's a very adaptable architecture in my opinion. But with all these great things, I think you kind of already heard some of this stuff from Adam's speeches, you really can't cheat physics, right? So you can have caching, and that'll work to cache stuff under those kind of optimal conditions. But a lot of times, if you've read kind of like sales literature, and it's like, well, you'll get all these IOPS off the SSD and all these ideal cases. The things work in the ideal case, but usually when you're having problems, it's not an ideal case. The system shut down during the middle of the day during your heavy workload, or things aren't working like you expect. And there's really no way in that bad situation to get out of it. So that's kind of where you got to realize you need to be able to plan for not just the best case, but also kind of the worst case too, because that's what you want to be able to endure. If you look at, having had a lot of experience in the VDI environment, if you look at kind of the Citrix and VMware View literature, it talks about, in a steady state, you only need 15 IOPS per person, you can save a lot of money, just scale your system this way. That's good once the system's up, but if you have to do something or the system goes down during the middle of the day, you need to be able to recover. So you need to be able to plan for those kind of worst case environments so that if the system does have a power outage in the middle of the day, you can still get out of it. So. And then what we've realized, and I think we know to be true, is that critical to a business, so these people are running their business operations on, in this case, our storage array, let's say. They need the consistency of performance, the reliability, and a sustainable performance. And so we've tried to architect solutions that do that, and ZFS has been very successful for us in providing that kind of reliability at different levels. Things like the data integrity, making sure the data is whole, the checksums, all the way up to mirroring and how you configure the system. So kind of want to talk a little bit about the typical journey that we've had dealing with a customer as they want to solve a problem. So typically, somebody's either calls us, they're looking for a storage solution, or they've been referred to us, or we have kind of approached them about, hey, consider ZFS or our product for your solution. It might be a better option for return on investment. It may be able to perform better than the storage solution you have because of the inherent features within ZFS. So the problem you often have, though, when you walk into these environments is that people don't really know their current state or what they're trying to solve. They know usually they either need more space or they need more capacity, or they just need things to work, right? Because in general, they're dealing with some sort of business challenge that they need to either have a website up or a database available that's providing their logistics support, and they just need it to work. So the capacity question's kind of easy to figure out. Somebody says, I have this much data, and I think for the near term, most of the cases, I'm going to grow or not grow, I'm going to stay kind of the same. But the data behavior is often unknown. It'd be kind of unlikely that we can walk into someone's environment and say, oh, what kind of applications do you have in your environment, and how do they write to storage? Are they writing in small blocks? Are they doing large sequential writes? Sometimes they'll have some custom database or application that they wrote themselves, and it kind of behaves how they want. So that's hard to capture. And then in certain environments, you get a guy that just says a budgeted amount of money, and he just says, I want to spend the money to get the best system I want, but I'm not really sure, how things are going to evolve in the future, or how things are going to change. And that can be difficult. You kind of need, to be able to predict what's going to happen there, you need like a crystal ball, or maybe like an oracle. Lost that, But then on top of that, you have kind of constraints. So a lot of times you'll say, here's how I would recommend architecting the system. So if you were at the conference over the past 2 days, you kind of get some good ideas, like, I really want to do things this way. But then some things like the budget will constrain you to do things differently than you would say the best practice or how you really want to do it. Or power, space, and cooling. So you're trying to balance those things and get the person into the best state they can be in, given either any kind of internal constraints they have. So the big influencers that can also change kind of that direction of where they go forward that I've seen has been, they start off, they have a kind of current state. Maybe you do have a good idea of where they are today. They get an application update, something like Exchange or something that completely changes the way they treat the storage after they've already purchased the storage system. So what was good now is completely broken because the new version of the software completely changes how it does things. Or all of a sudden there's an acquisition, they now have a new business unit, and they have this new type of stuff they want to bring into that environment, and that has a completely different profile for how it performs and behaves. And ZFS is good at adapting and handling different workloads. I'll talk about that a little bit. Or before you even got that storage system in there, they gave you incorrect assumptions. They said, yeah, this is how things work. They're confident. It's pretty hard to tell a customer they're wrong, so you kind of say, okay, I'll go with it. And then when you show up in the install and things start off okay and they start to deteriorate, it's kind of hard to go back and say, well, we talked about this, and this isn't exactly what you said. They kind of just say, well, this thing stinks. I'm not happy. So you get in this area where you're trying to fix it. So, and then the budget and economic changes. People think, hey, I'm going to grow. This year I need this. I'll just start off small, and then next year when I need it, I'll be able to buy more. Well, the budget doesn't come through. All those the plans they had fell through, but they still want to do all those things they were promised when you told them, yeah, you just have to do this. They still want to do it on a smaller system. So those are kind of the challenges I typically end up dealing with from a company provider. So kind of back to the Darwin thing, the adaptation leads to survival and success. And so to know how to adapt, you kind of have to understand your environment and be able to take that environment and adapt and choose decisions based on what you know. So coming to things like this, can help you understand, here's how things really behave, and using things like dtrace and tools like that, instead of just kind of going on your gut or your hunch, you're able to kind of use decision or data to drive those decisions. So, and then you can adjust quickly. And ZFS enables kind of that rapid adaptation by using things like cache device, changing the architecture, adding RAM, changing capacity, changing how the VDEVs and the disks are laid out, and kind of changes to even things in the software layer, the tunables, et cetera. So from that perspective, it's very resilient. So how do you know where you are? So here's kind of a screen picture capture of data analytic that's in alpha that we're trying to do. So we're actually going to collect data using collectors from things like kstem, dtrace, to measure things like the latency at the ZFS level, the VFS level, and the disk level, so that we can tell how the system's performing. And then we can do that across multiple systems, and so you can see how all of your systems are performing, and then you can see that in a way that we're going to push it into kind of our cloud ecosystem, so that you can see how does your system perform compared to other people that have similar systems, and then interpret that data to say, here's what this may mean, this is kind of indicative of this or that. It is definitely not a heat graph, so I'm probably falling short with the lines, but in person it's actually holographic. So, but we're measuring for things like hot files, latency, and IOPS. So the hot files thing I thought was pretty interesting, because I actually worked, I was at a client, and basically everyone had a program that was accessing a file in a shared directory. And what had happened was the file became corrupt. But the way the application was written, it didn't know how to handle this error problem. So what it would do is read in this file, which is fairly large, try to process it, find out there was some corruption, and then try to reread the file. So now all of a sudden, and this was a large environment, a couple thousand users, now instead of just kind of a couple thousand users reading this file over the period of a morning when they log in, this thing keeps being read and read and read, and it just sent the whole latency of the entire system out of control. Something like this would have kind of been able to immediately identify that and kind of say, hey, what is causing this, and then take corrective action. So this is kind of one of those problem-driven solutions. So, and then the other thing we're doing, which I think is storage knock, which is where we're fault monitoring customer systems. So we have kind of a phone home agent. We put this on their system, and then it sends us back some analysis and stats. And the real reason we did this was kind of selfish, because once the customer system fails, they're unhappy, no matter what, if it was their fault or if it's just kind of, hey, a dry failed or normal, they're unhappy. It doesn't matter whose fault it was or why it failed. So what we're trying to do is eliminate the problem before it becomes a real problem. So most disasters are kind of, multiple failures, not just one drive that failed. The drive failed, the hot spare that was there kicked in, but nobody decided to replace it or nobody noticed it. So this kind of says, let's take preemptive action and try to fix those issues before they become real problems. And so far, we're having kind of good success with that type of thing. So we're trying to kind of tie that into a complete ecosystem, which is what we call MyRack. And so along here, the health check is kind of a storage knock. We have some other things. The data interpretation would be the analytics as that goes. Right now, it's really in an alpha state, not even the data. The remote management allows you to basically see what's happening from a central portal across all your systems. So how is your replications going? how often are they failing, what percentage is each one of them completing. Replication in this is depicted by actually where we have a ZFS-DR service where we're actually allowing, so let's say you buy a storage system or you have a ZFS storage system or you've set up your own ZFS repository and you need a way to replicate it to an offsite, but you don't want to buy space at a colo or you don't want to have a second data center be charged to manage that. What we do is allow you to basically just replicate your ZFS data sets to us, and then when you need them, pull them back or push them from there into some sort of cloud, compute environment. Also, configuration management, we're enabling it so that you can have your configs for things like your syspools available, so during a critical kind of crisis, you can rebuild from a well-known or good config. So, and then unified communications is really about being able to have your view in the health of your system from anywhere. So having things like an iPhone or an Android app or a web page that allows you to see how's your storage behaving and performing. So being able to see that from anywhere you are. So it kind of concludes my talk, but I really can't say more than ZFS is super cool. It allows us to do a lot. We've bet our business on it, and I'm excited to see kind of the enthusiasm and all the progress that you guys are putting towards the community. And I think, as a company, we intend to put back to the community as well. So, yep.
A couple of questions. What problems have you hit with ZFS? And then if you have other advice to people about problems that they might hit and ways that you kind of proactively worked around them or worked around them after the fact.
So I think a lot of times, so the question was what problems have we hit with ZFS and how do we work around with customers? I think a lot of times things start off pretty well. The system under a certain load works pretty well, but what happens is people get enthusiastic about how well the system is working, and instead of this gradual decline, it's a cliff. And so then to back them out of that is tough. Usually it's, in addition to just adding some cache, there usually has to be physical spindles, because kind of like what you talked about with the L2 arc getting hot, there's certain environments where it works really well and you get a lot of cache hits, but there's other environments where you can't escape the physics. You need the number of spindles and physical persistent drives to be there.
Thanks to that working sets hash conversation.
Yeah, right. And getting people to understand that, how the system behaves, and getting them to really understand the forethought. How do you really want to configure the system? Do you really want to do a RAID Z2, or do you need to do the RAID 10 to get the performance you need and sacrifice a little bit of space? So that's usually the biggest conversations we have, and they directly tie to dollars. So.
It's always the ones that they want tons of space with a ton of performance.
Can't have it all.
Can. More zeros.
We're serious.
There's a question on the stream. What was the 8 gig ZIL device with supercaps mentioned by Adam?
Zeus
Zeus
RAM.
RAM.
Fish RAM?
The SDEC Zeus RAM.
Oh, Zeus RAM.
Yeah.
What OS do you run?
So we're running ZFS today based on Accent OS.
What would you like to see in ZFS? What's missing?
So I think we definitely want more to expose more of those kind of, and that's what we've been putting a lot of our effort to, on top of the file system level, is basically saying what's happening, to understand how your data is behaving, how do your applications treat the storage, and then to make kind of good reference architectures. I think that's what we are striving to do, to say, hey, if you're setting up an Exchange environment, this is a good way to set up. If you're setting up an OpenStack environment, here's kind of a reference architecture to go from there, and more kind of introspection into how things are working and behaving. So, the people that are going to make these decisions, it's got to be in that kind of business speak. So if you want the CIO or the business decision maker to say, yeah, this is the right investment, and we should be using this over that, it has to translate into kind of a business case, and being able to easily translate the bytes into business case language is kind of critical. Yeah, sorry.
So in terms of ZFS, what advantage does it give your customers over, let's say, you buy a NetApp box or EMC box?
So I definitely think, depending on your use case, number one would be the return on investment. You're getting more more either performance or capacity for the dollar. And then I think also equally important to a lot of customers is the data integrity, the ability, the independent checksum, and to know your data is kind of intact, and to know and to be able to auto heal. So.
Visibility to the system, really. I think that's what it boils down to a lot of times. Because people are surprised by what we discover.
Yeah, a lot of times, like, some of the other boxes tend to be a closed box, and by exposing kind of some of that information about how their data behaves and how the system's behaving can be helpful for them to make the next decision, right? Because usually, especially in a storage environment, you don't usually just buy a storage system and then wait 5 years. You're typically either growing or getting another one, and the more you know about how your applications behave, you can either tell the developer, change the way you behave if you control the development, or kind of build around that if you have no control over them. All right, thank you.